Hi, Mark Donovan here from Falcon Imagery, and today I'm going to be going over cross-country flight planning. Cross-country flight planning is a major component for those working on their private pilot or even their instrument commercial ratings or certificates. For the private pilot, you need 3 hours of cross-country flight training in an aircraft, and in addition, you need to perform 5 hours of solo cross-country flight. And so what I'm going to do today is go over the first major component associated with cross-country flight planning, and that is filling out a navigation log. The other components associated with cross-country flight planning include the weight and balance calculation, takeoff and landing performance calculations, and then filling out and filing a flight plan for the cross-country flight. So today's lesson is going to be exclusively about filling out the nav log, and subsequent lessons will talk about those other topics. If you have any questions or comments during this session, leave them below. I'm using a Jeppesen navigation log form. There are many out there that you can use. They're all very similar, but that's what I'm using, and I'm basing some of the information off a Piper Warrior, though I do try to keep the presentation generic so that it's transferable to any type of aircraft. All right, so follow along, and if you've got any questions, again, just leave them below or email me. I leave my email contact information in this presentation. All right, let's get into it. Cross-country flight planning, filling out a navigation log. So there's a few key tools that we need to use when doing a cross-country flight plan, particularly filling out the nav log. We need a plotter, an E6B whiz wheel, just the old school type, and then if you elect to, you can purchase an E6B electronic computer. That's optional. They're quite a bit more expensive than the E6B whiz wheel. And frankly, the E6B whiz wheel is quite easy to use if you spend a few minutes reading up on it. Of course, you need a sectional chart, and you also need the aircraft pilot operating handbook in order to look at the performance charts in regards to climb and cruise performance during the cross-country flight. So what are the key deliverables? So the deliverable package consists of a Jeppesen VFR navigation log that we're going to fill out today. There are other manufacturers out there of navigation logs, but that's the one I'm going to use for this lesson today. You need to do weight and balance. You need a takeoff and landing distance to clear a 50-foot obstacle sheet. You need to fill out an ICOA flight plan sheet as well. And then lastly, I'd like to see a chart supplement or airport directory file for printout for each airport. Also, flight plans must be filed with the flight service. You can call 1-800-WX-BRIEF to file the flight plan, or you can submit a flight plan on their respective website, or you can submit a flight plan via ForeFlight. In addition, all flight plans should be activated and closed before each and after each leg of a cross-country flight. You can use flight services free and easy access, easy close utility by signing up on an account for 1-800-WX-BRIEF, or you can use ForeFlight to activate and close flight plans. In addition to use of flight plans, you should also use flight following radar surfaces from ATC. These are a great tool to take advantage of. This service is a great tool to take advantage of. Because we're talking you're a sole pilot, student pilot on a cross-country flight. Why not have another set of eyes that are keeping an eye out for you to making sure that there's no traffic in your area and that you're going the right direction. Prior to every cross-country flight, you need to obtain a standard weather briefing from the flight service operators or flight service briefer. You can call 1-800-WX-BRIEF to get that. Highly recommend. I insist upon it with my students. You can also go online to the flight service, www.1800wxbrief.com, sign up for a free account, and then do your own briefings. And you can also look at using ForeFlight. These latter two methods, I really recommend that student pilots don't use them initially because they're not going to be able to interpret what the data that they see on those briefings are. So by calling and speaking to a briefer, if there's any questions on what's being provided to you for information, you can always ask them. In regards to calling a briefer, if you call 1-800-WX-BRIEF, be prepared to provide them with the aircraft type and registration, the departing airport code, the destination airport code, the time of your flight, how long you expect it to be en route, and your cruise altitude that you'll be flying at. So with the Jeppesen VFR navigation log, you should print one out because we're going to do this by basically pencil and paper. And you're going to be filling in this table with all of the information that you see listed below. I'm not going to run through this list because it's quite long, and we're going to be covering every one of these things individually here throughout this lesson. So first, we're going to plot our course route on the sectional chart. Using a plotter and a pencil, mark a thick straight line on the sectional chart, as you can see here. Make that mark from the departing airport to the destination port, just a nice straight line. Use the protractor on the plotter to determine the true course route. And I have a separate video on that that can show you how to use the protractor on the plotter to determine that true course route. Enter the true course in the first box below the navigation, right there. It says where it says true course. This is where we want to put the that first piece of information into the nav log, and that's going to be the same true course the whole length of the flight. Next, we're going to enter the departing airport code and determine its pressure altitude. Enter the departing airport code, KLCI, as the first checkpoint in the nav log, as you can see over here on the right. They're going to enter the departure airport's field elevation and MSL into the nav log. And we're also going to make note of using the E6B pressure altitude calculator, E6BX, to determine the airport's pressure altitude. We're going to make just a side note of that information because we're going to need it later on for determining the performance climb of the aircraft as we begin this cross-country flight. If you remember right, pressure altitude is true altitude corrected for non-standard pressure, and density altitude is pressure altitude corrected for non-standard temperature. But in here, we're putting our airport field elevation, and we're just keeping as a side note what the pressure altitude is for the airport on the time of the flight. See my videos separately on how to calculate pressure altitude and density altitude if you want to learn more about how those numbers are derived at, as seen in this screenshot of this e6bx.com website. Enter the departing airport's forecasted wind and temperature information. You want the wind direction, velocity, and temperature. You can get that from the METAR or preferably during your weather brief. Next, enter the aircraft's true airspeed into the nav log for the climb performance. See the aircraft's pilot operating handbook to determine the climb performance for true airspeed. In Section 5 of the PH is where you can find that information for the Piper Warrior, and it's fairly common with other general aviation aircraft to find the performance characteristics in Section 5. Enter the true airspeed for the climb in the top box just below the label TAS into the nav log. Next, we want to determine the cruise pressure altitude. Observe the maximum elevation figures along the route of flight that the true course traverses along the flight path. Look for the highest maximum elevation figure you run into. That's this MEF. These represent the maximum altitude of an object or a mountain in this kind of GPS segment area here. And we want to look along the whole route to see which one is the highest number that we run across. And here we see coming out of Laconia and up to Auburn Lewiston, we see 4,600 feet of an obstacle here is the MAF. We want to choose a cruise altitude to fly it from the departure airport to the destination port that is approximately 1,000 feet higher or preferably higher than the highest en route MEF, and that also complies with the VFR cross-country cruising altitude rules. If you're flying on a magnetic course heading of 0 to 179, you want to fly at an odd altitude of 1,000 feet plus another 500 feet. So you'd be flying at something like 3,500 feet or 5,500 feet along the route of flight. In this particular case, heading up to Auburn Lewiston, because we're going to be heading on something that's between 0 and 179 for eventually magnetic heading. If you're flying on a magnetic course that is 180 to 359, let's say you're going from this direction toward the southwest, you're going to be flying at an even altitude that's in thousands of feet plus 500. So something like 4,500, 6,500, etc. Enter the cruise altitude in MSL feet in the nav log just below the airport field elevation. So we're going to cruise at 5,500 for this trip, and that's what we would put in here for our cruise altitude. Use the E6B pressure altitude calculator to determine the pressure altitude your aircraft will be cruising at. So if you're planning, for example, to fly at 5,500 feet, MSL, you'll need to factor in the offset between the airport field elevation and the airport's pressure altitude. For example, if the airport pressure was 300 feet less than the true field elevation, airport field elevation, above sea level, then subtract the same 300 feet from your planned altitude, cruise altitude of 5,500 feet to represent the cruise pressure altitude, for example, 5,200 feet. And so when you're reviewing your aircraft's cruise performance charts, you'll be looking at the pressure altitudes associated with 5,200 feet and the corresponding temperature at that altitude. So we'll put in here the 5,500 feet, but we're going to look at the 5,200 foot pressure altitude in the cruise performance charts. Next, we want to determine the fuel time and distance to top of climb. Enter label top of climb checkpoint in the nav log just below the departing airport checkpoint code. You can see right here at top of climb. Enter the winds temperature information for the top of climb, or which was effectively your cruise altitude, adjacent to where you have the cruise altitude here on the right. Find the climb performance chart in the pilot operating handbook and determine the fuel time and distance to top of climb. This is to basically calculate your fuel burn to get to top of climb, your time en route to get to top of climb, and your distance from the airport to the top of climb. Make sure when using the chart to factor in the airport's temperature and pressure altitude that you determined earlier. Enter the fuel time distance information into the nav log where you see distance, estimated time en route, and fuel burn. Next, we want to determine the cruise true airspeed and the fuel burn rate. So determine the aircraft's true airspeed for cruise performance by, again, looking in the aircraft's POH to determine the aircraft's cruise performance. In Section 5 of the POH, again, for the Piper Warrior. Use the best power cruise performance chart associated with your aircraft's specific serial number. Use the chart by factoring in the cruise temperature and cruise pressure altitude. Work your way across the chart and plan to use a 65% power throttle setting to find the cruise true airspeed. Note that the true airspeed for the aircraft, remembering to subtract the appropriate number of knots if the wheel fairings are missing from the plane or not on the plane. So for example, a 65% power throttle setting with best power, you're going to be somewhere around 23 to 2400 RPMs for the aircraft and cruising approximately about 97, 98 knots. Enter that information, the cruise true airspeed, in the true airspeed box of the nav log, starting with the top of climb and other checkpoints. So effectively, from the top of climb here all the way to your arrival at your airport, that's what you're going to put in for your true airspeed. Also note the gallons per hour fuel burn in the table for the 65% power setting and enter it in the gallons per hour box in the top right of the nav log. For the particular Piper Warrior that we're flying at 65% power throttle under best power cruise, we're looking at around 8.8 gallons per hour. Find the wind correction and true heading and ground speed in cruise. So again, you want to watch my video on how to determine the wind correction using an E6B whiz wheel. Determine the wind correction at the departure airport field elevation using the E6B whiz wheel and enter the course route in the top box below the top column, or the TC column. So you see here we've got our course route we're going to put here, and then we're going to enter our wind correction value right here, and then we'll sum the two of them together, and the sum of those two will go here for our true heading. Note the climb ground speed performance on the E6B and enter that in the top ground speed box over here on the far right. Determine the wind correction at cruise altitude using the E6B whiz wheel. Again, enter the course route value in the next box below, right here. Then factor in your wind correction that you figure out in your whiz wheel. Sum those two numbers together, and that'll represent your true heading at cruise altitude. And then enter the result of those two right there for your true heading. And again, note the cruise ground speed on the E6B calculator and enter in the ground speed boxes below. So you'd put your cruise speed in this box here, and this box here, and so on. Next, we want to find the magnetic variation associated with our route of flight. And this is where we look at the isogonic and agonic lines on the sectional chart. And these lines represent equal lines of magnetic variation. They're represented by these magenta lines here that you see here, and you see 15 degrees west. So again, look along the true course route line that you drew with pencil on the sectional chart for the agonic or isogonic line that traverses the flight route. And again, isogonic and agonic lines reflect equal lines of magnetic variation. It's also important to note that the true North Pole is not at the same location as the magnetic North Pole. They're not coincident with each other. As a matter of fact, the magnetic North Pole is about 1,300 nautical miles away from the true North Pole. Note the number on the isogonic line that you see here, 15 degrees west. This is the magnetic variation. Enter the magnetic variation value in the nav log just below the true heading. So we got our true heading, and now we're going to see we saw the plus 15. We're going to put plus here because it shows a west. If it's west, it's a plus. If it's an east, it's a minus. So we'll put plus 15 in there. Sum the two of those numbers together, and that will go into your magnetic heading area. Do this procedure now for both the airport and the topic line checkpoint. So you're going to figure out that magnetic variation or magnetic heading based on the true heading that you're flying both at the airport when you start as well as in cruise, and then summing up the numbers for each pair of these boxes and then putting the particular magnetic heading over here on the right. Factoring in magnetic compass deviation. Compass have number of errors associated with them, and it's mainly applicable to the avionics in the aircraft, in the metal in the aircraft, affecting or even the placement of the compass that affect its ability to show really true north when facing north. So there should be a compass deviation card that you find next to the magnetic compass inside the aircraft. Take a look at that and observe what the compass deviation is based on the magnetic heading value that you've calculated to fly. Enter this compass deviation value just below the magnetic heading entry you previously calculated. That's here represented by this plus 2. Make sure to note if it is plus or minus deviation that you should enter. Sum the two numbers together, the magnetic heading plus the 2 here, and the sum of those goes in the adjacent column as your course heading. This is the heading that you're actually going to fly in the plane. You're going to see this on your directional gyro or your heading indicator. Do this procedure for both the airport elevation that you're departing from and then in your cruise altitude. And these again are the directions you're actually going to steer the aircraft when flying it on the cross-country flight. Now, so we need to select some checkpoints along the route of flight. Make a thick, short penciled mark line that runs orthogonal to the course route to show the top of climb. That's this line right here. Then every 10 to 15 miles along the routes, starting from the top of climb, find and mark a checkpoint that you could expect to see from the air during the flight. This distance here is a little bit less than 10 nautical miles, but I picked it because it was a very easily seeable checkpoint to use. You want to pick checkpoints that can be easily seen, clearly seen, that either beam the route of flight or directly under it. And I picked this one because I had a nice, well-defined round lake off to my right. Good checkpoints include populated areas like lit areas like this. Any place where you see yellow, that's a populated area. This little area here is lit up, so there'll be some more buildings or a town here. You also want to pick potentially large, unique bodies of water. I picked this pond here, there's a big lake here, there's a pond here, all along the route. In some cases, there are wind turbines that are good places to use, or railroad tracks, or power lines are another option, or large tower structures, which you see right here that I've picked for my next checkpoint. And then lastly, I got a checkpoint here where there's a big tower line, a tower, and a round pond or lake. Enter these checkpoints routes of flight into the nav log. Enter them in order that you see along your route, starting with your top of climb. From there, it's the round pond on the right, the midpoint between the towers, pond and tower on the right, and then the final destination airport. The last checkpoint, again, is the destination airport. I will say with this that I've made my distance from the pond tower is my final normal checkpoint to the airport, a distance that should be such that I should be able to see the airport when I get to this checkpoint. And also it's a good point to begin my descent. And a simple general rule about when to descend or top of descent. I could have put another checkpoint here with the top of descent, but my rule of thumb is, based on the math, is if you take, for an aircraft that's flying, these class category A aircraft that are flying, let's say 90 knot ground speed, if you want to descend at 500 feet per minute, the general rule of thumb is subtract the difference from your cruise altitude, take the difference from the cruise altitude and your pattern altitude that you're going to be going into for the airport, in this case KLU, Take that difference, multiply it by 3, divide by 1,000, and that'll tell you how many miles you should be before when you should start your descent. And this is again assuming a descent rate of about 500 feet per minute and a ground speed of 90 knots. That distance away from the airport to start your descent will depend upon, again, your your ground speed, and your altitude you're cruising at relative to the airport you're planning to land at. Enter the distances between the checkpoints on the nav log. So over here, use your plotter to measure the distance in nautical miles, not statute miles, nautical miles between the checkpoints. And I've got them listed in here. Start by measuring the distance between the top of climb mark and the next checkpoint mark you made on your sectional chart, and record that distance in the corresponding distance row box in the nav log. And what we see here in the circle. Repeat this process between all of the checkpoints, including the last route checkpoint and the destination airport. Next, determine the time and route between the checkpoints. For all the checkpoints from top of climb to the destination airport, determine the time and route between the checkpoints. Again, use the E6B whiz wheel to determine these times. I've got a separate video on how to use the E6B whiz wheel to determine time and route between checkpoints, so check that video out. Record the various times between the checkpoints in the respective estimated time and route boxes on the right side of the nav log. Next, determine the fuel burn between the checkpoints. For all of the checkpoints from the top of climb to the destination airport, determine the fuel burn and route between the checkpoints. Again, using the E6B whiz wheel, you can do this, and I have a separate video on how to use the whiz wheel to determine fuel burn between checkpoints. Record the various fuel burns between the checkpoints and put them in the respective fuel boxes on the right side of the nav log, as you see here. Now, sum up the distances, time, and fuel burn between the checkpoints. So basically, we're going to just sum up all the numbers here for the distances, the time, and the gallons per hour fuel burn that we've got, or fuel burn that we've got per leg. Confirm that the total distance that you calculate equates to what you measure with the plotter on the sectional chart. Sum up all the time calculations between the checkpoints starting from the departure airport to the destination port. And again, just roughly see if they make sense. And enter them in the bottom of the chart. And then lastly, enter the fuel burn calculations and sum them up. I will say, as a side note, remember this is the amount of fuel burn from the departing airport to the top of climb, and then your fuel burn between the various segments. You need to also factor in the fuel burn for taxi and run-up. Per the POH, they typically will say how many gallons you may burn for taxiing and in the run-up. For the Piper Whirr, we use roughly about 1.5 gallons. So we would add to this total another 1.5 gallons of fuel to estimate the total burn we're going to have from when we start the engine to when we arrive and land at the airport at our destination. Next, we want to enter the airport's frequencies and field elevations. So over here, this box right here. In the end, we want to have one sheet that we're working from on our cross-country flight versus a bunch of loose sheets laying around the cockpit. That is everything we need to know about the trip. So here we'll enter info about all the various frequencies for that airport, both the departing airport and the destination airport. And down here, we'll put in the field elevation of each. So we have a clue what altitude we need to fly for the pattern once we get into it. Look at the chart supplement for the destination airport. Again, get all that information about it, enter that into the nav log. And then again, previously, you want to put in the departure airport's information. The final entries to the nav log. Enter the aircraft's registration number at the top header, enter the departure and destination airports. And then lastly, I like to put in a picture of just a hand sketch of the airport runways that I'm going to see. And I put them in a couple ways. One, the relative magnetic heading that they're going to be on. And I'm flying a magnetic heading toward them. So I have a perspective of where I should see them out the window of the plane when I'm looking. And then the relative size in relationship to each other. So runway 1735 is a very short runway up at Kalu compared to runway 422. I also know it's narrower than 4 and 22. So I'll take most likely a crosswind that's reasonable crosswind component and land on one of this longer runway than take this short runway. So that's the process for filling out a nav log for a cross-country flight. It's rather long and tedious. However, it's very useful, particularly for the private pilot, student pilot, because it helps to get a better understanding of all the factors that come into determining what heading you're actually going to fly, magnetic heading, you're going to fly when you're in the plane on that cross-country flight. Knowing how to factor in wind correction, magnetic variation, and compass deviation are all important subjects to fully understand. Using ForeFlight to get to the end solution is a great tool. It speeds up the process dramatically, but you can forget or miss understanding the steps along the way that actually get you to the end result of what your magnetic core segment you're going to fly. Similarly, making sure you clearly understand how to use the POH in the terms of the performance for climb performance and cruise performance, critical that you understand that. So anyways, I hope you found this video useful. If you did, consider hitting the like button and subscribing to the channel so you get notified when I come out with my next video. And particularly, I'm going to have another 3 parts to this whole cross-country flight planning segment. So again, it's important that you understand all the steps in flight planning, and encourage you to, again, subscribe to the channel so you get notified when those next videos come out.